I am Yasitha Gamage and let's talk about linked list. What is a linked list? A linked list is a linear data structure where elements are not stored at contiguous memory locations like in an array. In linked list, it's basically a collection of elements which are linked together. Each element is a separate object which is also called as a node. A node is a basic structure which can store data and reference to the next node. So, as an example, you can see in the screen, I have four objects or four nodes. Each node has its data in it. It's 2, 4, 6, and 8. So, a linked list is a collection of elements, a collection of nodes. So, how to make a collection? It's basically, as I told before, each node holds the reference to the next node. In linked list, the first node or the first most element is referenced as head. This is a really important concept because each and every time when we go through a linked list, head is an important factor. So the first node or the node with the value 2 will be the head node in this scenario. So it will reference as head. And now I should have a reference to the node where it holds data 4. So this node will be held in this first node I created as a reference. So here it will hold the reference of the second node with the data 4. And the second node will hold the reference of the third node and so on. It will keep on linking using pointers. But still, the last node, it won't have any reference, right? Because it won't have any node afterwards. So the reference of the last node will be null, which we can also call as the tail, because it's going to be the end of the linked list. Head is going to be the first node or the starting point of the linked list, and the last node or the tail, which we're going to call it tail, is going to be the last node where the reference is null. So we called it tail. This is what basically linked list is all about. We can add elements, delete elements, and keep on going through the linked list, sort the linked list, and we can do so many executions in linked list. Of course, Java has its inbuilt linked list option, but still, today we'll look into it and see how to implement our own linked list in Java. Going more into linked list, I told you it has a node and it should be linked. This is a very important concept in linked list, which makes linked list a dynamic data structure, unlike an array. Because in an array, if it defines it, it will hold a limit and we can't exceed that limit. But in linked lists, as we are having nodes and each time we add an element to a linked list, we create a separate node and link it with the node beforehand. So we can keep on extending linked list without any limits. So this makes insertion and deletion of data bit easier when considering with arrays. But still, there are some drawbacks of linked list as well. In arrays, we can randomly access any point of an array using indexes. But here in linked list, we can't use indexes, or we are not allowed to use random access. The thing is, in linked list, if we need to go for a certain position to get a value, we need to start from the head. As I mentioned, head is an important point. We need to start from the first node and keep on going till we get the position we need. So it's a drawback. Of course, it takes some time than an array. Once again, unlike arrays, linked lists take more memory than arrays because it have to store pointers as well. And arrays have better locality when we consider about cache compared to linked list, since array elements are stored in contiguous memory locations. so it will be fast and reliable when we access those stuff. But considering about the dynamic way of storing data in a linked list is far more better in considering about inserting a lot of data without any limits. There are a few types of linked lists. What's going to be simple linked list, double linked list, and circular linked list. Today what we're going to do here as example is simple linked list. It's going to go one way. The pointers are going to get in one direction. It's going to go forward. But in double linked list, it's two-way. It can go forward and backward both. So it's linked in forward and backward both the ways. In circular linked list, it's quite a different way where the last node will hold a reference to the first node. The tail node will hold a reference to the head node, where it's going to make it a circular linked list. So in a list, what we have as basic operations is insertion, deletion, displaying the list, and going through the list for some values. So we'll see how to implement linked list in Java. And before moving into that, I need to tell you guys, here we talked about the head node, which is going to be the first node. This will be the entry point of a linked list. The head of the list is going to be the entry point. And we should note that the head is just a reference to the first node and it's not a separate node. And the last node, it's always going to reference a null because it won't have a reference to a node, which is we're going to call it as tail. Just imagine if we don't have any elements, it means we don't have any nodes, then the head will be null. So let's move on to our code in Java. Okay, come back. Sorry. When we talk about our own implementation, we need to have an object which we called as node. So we need to create a node class to have the node object, which is going to have the data and reference to the next node. And the linked list class will basically have the execution of our methods, insertion, deletion, and display of the linked list, and sort of stuff. And the test class is to demonstrate the linked list that we implemented. Let's move on. So first, I'll start with the node class. So here, what we're gonna have is first the data. I'm gonna have integers. You can have floats, boolean, any type of data, maybe objects, passengers, cars, anything. But still, when I'm going to store the reference, it should be a node because every node will hold the reference to the next node. So it's going to be a node. So it's going to node, as it's going to hold the next reference, I'm going to call it next. So that's it. I'm done with the node class and I'm going to go with the linked list class. Of course, Java has its inbuilt linked list, but it doesn't matter because we are working in the same package. And now we need to make our test class to go with our demonstration. Okay. So now I talk about head, which is going to be a so important point in linked list. So to go through a linked list, head is a must. So I need to store the value in head. So I'm going to make a node for head and that's it. Now the first method. We should start with inserting data into a list. So I'm going to create a method public void insert. And I should pass a data in order to be linked with the linked list. That will be an integer the moment as I'm going to store integers. And coming here, now we have an object of linked list. Okay. Now we need to insert a value to the linked list. This is test class, is the main class, so we need to have a main method in it. And now we can create our linked list object. Using the insert method that we created, we can insert a value. When I consider this line 6, it's linked list dot insert 2. This will insert the value 2 by creating its own node. So what we need to do in the insert method is we need to create a node and tell that we're gonna pass that. And here the node will be new node, and we need to put the data to that certain node. Okay, that's it. And now think, what if we don't have any data within the linked list, and if it's gonna be the first node or the head of the linked list? So we need to check whether the head is null or not. As I mentioned, if head is null, the linked list will not have any data. So what I'm going to do is I'm going to check whether the head is equal to null. Of course, if it's equal to null, then the head should be the new node that we created just now. Else, this means the next scenario. What if we have an object or a head already created in the linked list? It means we have data in the linked list before. So what we need to do is, in a linked list, we should go to the last element or the last node, and after that node we should add our new node, because each time we insert, it's going to be added to the last point. Just think, we have 2 added. So what I need to do is I need to check the position of the node which holds the value 2, and afterwards after that node I should place a new node that I'm going to create now, which is going to be 4. So how to check? As I told, we can't randomly access in a linked list. We should start from the head and move on for the position. So what I need, I'm going to create a node called n and make it equal to head, as we need to start moving on from the head. And if you can remember that I told that the last node will hold the reference of null. So to get the last node, what I need to do is I check whether the last node, the node which I'm going to take the reference, whether it's null or not. So what I'm going to do is I'm going to loop through the linked list using a while loop and check whether the reference of the node is equal to null. So if it's not equal to null, what I can do is I can keep on moving to the next node. So I'm going to send n equals n dot next. N dot next. What is this? Because if this is going to be the second node, the third node will be the reference of the second node. So n is equal to n dot next, which is going to refer to this node. So that's it. Now after this loop, it will stop at the null point. It means it will stop at the last node. So now what I need to do is I need to add the data to the last node, to the last reference. So I can say n dot next, take the reference and make it equal to node. That's it. So I think the insert stuff should work, but still we can't make sure because we can't see the values in the linked list. So what I'm going to do is I'm going to create another method to display what we have in the linked list. I'm going to call it show method, and the show method, what I'm going to do is I start from the head and keep on printing the values till the point of the last node. So I need to start from the head. So I'm going to create another node which is going to equal to head, and same here I need to use a while loop because I'm iterating through the linked list where I'm going to check whether the reference is null. So if it's not null, I should print the data in every node. And I need to keep on moving from one node to another. So in dot next. That's it. So I hope, oh wait. As I told, this will loop out until the node where the reference is null. It will point out to as here it got the reference of the second node. It will print out for as it got the reference of the third node, and this will print out as it got the reference of the fourth node, but value 8 won't get printed out as the reference is null. So the loop exits at this point. So what I need to do is take the value after that and print out that thing. So it's gonna be the last node. So I'm gonna print the last thing. Hope this should work. So we'll insert the other two data as well, which is gonna be 6 and 8. And now we have our show method which we created just now. And let's test whether it's gonna work or not. Nice. Here we got 2, 4, 6, and 8. That's the basic implementation of the linked list.